students, welcome back. We now want to go to the tutorial 3.2. Hopefully you have finished the tutorial. Okay, now I show the objective answer. Okay, this one until question 13. Okay, all the objective answer is here, so make sure you check it. If you don't know, that means you can PM me to ask how to solve the question. Okay, now I want to go is a question structure. There's a question 14. Okay, question 14, they show about two permanent magnets. Okay, two permanent magnets with the different pole. There's a north and also the south. They place closer each other. So now the first one question, they want you to draw the pattern of the magnetic field. So when we draw the pattern of the magnetic field, just a normal line, straight line. From the north go to the south, then you label the direction. Okay. Next one, it should be the two wire, the straight wire of the current they flow through, but in opposite direction. Remember the catapult field, when the current flow in same direction, I told already, the shape acts like the mass. Mass means the outside, the force, or you say the magnetic field, they will join together, and the force they will attract. But this one, the current is the opposite direction. When the current in opposite direction means they will separate. They never close to each other. So from here, we need to split out first. The left hand side and left hand side, we go to finish first. Okay, we go to separate each other. Okay, now we need to draw the center line. Okay, remember the center line, the force is strong force. Strong force means the direction should be the same. So strong force, you also need to draw the line, become closer. So I want to complete this one. So from here, I need to draw the circle closer at the center. Okay, this one also same. Okay, the center become closer. Okay, direction for the dot. Dot is come to me, there's an anti-clockwise. This one is a clockwise, so also up. So you find it at the center, all the directions should be the same. All go up. Last one, we go to label the force. Okay, the force is repel to the each other. Okay, so this one is a two catapult field for the straight wire current in opposite direction. Okay, now we go continue with the C. C, they show the straight wire in the figure B is placed together. Now you bring the current together with the magnet. Okay, now we got two catapult field. No catapult field, got two magnetic field. One is a current, another one is a magnet. So now we can using the Fleming to find it. Where's the direction, the forces acting to the object. So let's see the first one, north to south. So we point our finger, left hand side. Okay, so this one is a Fleming. So I take out the first finger, I point north to south. Okay, second one, we see this one. Dot means come to me. Come to me, I take out my second finger, I point myself. When I point myself, I bring my thumb up. So you see the thumb is go upwards. So the thumb go upward means the force acting up. So I label first. This one is a force go up. This one is a force come down. So remember when we draw, okay, you must know the force go up means down becomes strong region. So that's why they're acting. The magnetic field go up. So from here we need to draw here become curve. This one become curve. So when I just draw, I curve a little bit, then up. So this one continue to draw curve and up. So make sure the part curve you must draw become closer because there's a strong region. Okay, the rest is okay. Just draw the normal line, follow the shape. Finish. So this one is a magnetic field line. Okay, now we need to draw is a forces and also direction. Okay, direction must from the north go to the south. So we just label the arrow. Okay, last one is a force. You draw the bigger direction go down. Then you label this one F. Another one is a force go up. Then you label this one is a F. So this one we finish the question C. Okay, we draw the magnetic field. Then also label the forces. Okay, then we continue with the D. Suggest the two methods to increase the force. How to make these two forces become stronger. So we're still using the Fleming. Okay, we're using the concept for Fleming. Okay, you want to make the force become stronger. These two must be stronger, is it? Because there's a directly proportional. So the first one you can say, increase the strength of the magnetic field. Okay, increase the strength of the magnetic field. Okay, number 2, increase the magnitude of current. Increase the magnitude of current. So this one is a 2 factor, how to make the motion or how to make the force become stronger. Okay, next we go to question 15. Diagram show the arrangement of an apparatus to investigate the interaction between the current carrying conductor and the magnetic field. Okay, this one is show that one of the diagram for the wire X to rotate. Okay, wire X is either rotate, go in the magnet or either go out the magnet. So this one is a 2 situation. Okay, so from here we go to answer the first one. Name the type of the magnet we use. So this type of the magnet we call what name? Okay, you can refer the first page for 3.2. The first page already show you the diagram. Okay, this one is a U-shaped diagram, is it? The U shape, we call it as an iron yoke. Okay, but you see the U-shaped iron yoke, up and down, they got attached the magnet. So this one magnet, we call it as a magnetized magnet. Okay, so you please answer in your notes, your exercise tutorial. They can mention this one we call what magnet. So your answer is a magnetized magnet. Okay, now when the switch just closed, indicate and label the direction of the current to flow. So that means you need to label the whole circuit, the current how to flow. Important is the wire X when they're below the magnet. I just want to know the direction for that part only. The rest is okay. Because we need to know that part because I want to show about the Fleming left hand. Because just got that part, they got interaction. So that's why we need to know the current is how to flow on that part. Okay, so now I draw first the diagram, then I show you how the current to flow. For the student, we continue for the diagram. Okay, just now we say about magnet, is it? Now we need to find out to indicate the current how to flow. So we find it, this one is a positive, is it? So the positive, that means the current will start here. So end with here. So from the middle, we need to find where they flow. Okay, they flow down, wire X. So up, then go back. So that means important is this part, wire X. So this part you need to see the arrow. So if I stand here, means the arrow is far away from me. Far away from me, that means later, the second finger you cannot point yourself. You must point another way. Okay, now north to south. North to south, we know already the direction must go downwards. Okay, when go downwards, so you need to point downwards. Okay, now when I show the finger, you see the second finger point myself. So I need to rotate. Rotate the second finger far away from me. Okay, so if I far away from me, where's my thumb? My thumb go to left hand side, is it? So if I never point, I never turn, I take the second finger point myself, my thumb is go to right hand side. Okay, let's see this one diagram. So if I position as this one diagram, so you can see my finger down, okay, far away. So I need to turn like this, the situation. So can I see my thumb? My thumb is go to left hand side, my left hand side. So left hand side means that we move here. You sink to this part, left hand side. Okay, so from here, finally I find it. This one wire X, that will move to the inside the magnet. Okay, inside the, you cannot say magnet. They move inside the iron yoke. Okay, you also can say they turn to the left hand side. Okay, so your answer is move to left hand side. The wire X move to left hand side. Okay, then they ask, give the reason why you say like that they will move to the left hand side. Important is resultant force. Which one to move it? The forces. Because your interaction, you produce the force, is it? So from here, your answer is because of resultant force acting on the wire X. So this one is a reason. Okay, then we say suggest the 2 ways how to change the direction of the motion of the wire X. So that means I want the balik. I want to make the wire X go to right hand side. What you need to do? So the first part, you go to reverse the terminal of the battery. When your battery current flow in reverse direction, so you find it later. This one wire X, they will rotate, go to another side. Or you say another one is you go to reverse the polarity of the magnetic field. Okay, north and south. Now you go to reverse. South you put at the top, then the north you put to the down. So after that, they will reverse back the direction. So either one change, you cannot both do the change. If you both go to change, actually it's nothing happen. So your answer here you need to write is reverse the terminal of the battery. Number 2, reverse the polarity of the magnet. Okay, polarity spelling. Okay, polarity. Reverse the polarity of the magnet. Okay, next we go to question 16. Question 16 is a motor. So this one there's a DC motor because they're using the battery. Okay, so from here we see the diagram. They got carbon brush. After that, the X. They call you to ask you what's the X. After that, they show the magnet. Then they got coin. But the coin, they never tell you how to rotate. Just like this only. So from here, we're going to see the first part. What is the function of the motor? Okay, this one DC motor. Okay, actually, is what's the function? Normally, the motor they use to rotate something, is it? To make it the coin, then after that rotate. So function for the motor, actually, they want to convert electrical energy to the, when you rotate, what energy? There's a kinetic energy. So function for motor to convert electrical energy to kinetic energy. Okay, next. Label X. What's the name? The name is a commutator. Okay, we know there's a commutator. Okay, C. What's the function for the carbon brushes? We got 2 carbon brush here. So what's the function? Actually, the carbon brush, they're just at the middle. They want to contact between the battery and also the carbon brush. So that means battery, they produce a current, is it? So the current will flow through the carbon brush. Then the carbon brush let the commutator got current. So this one is a function for carbon brush. So we just write contact with commutator and also power supply. Okay, just contact to each other. Okay, contact to commutator and also power supply. Okay, next, based on the diagram, can you state the direction does the motor rotate? Okay, when the current just flow. Okay, so from here we need to label first. Label the current how to flow first. So this one we start with positive. So the current flow through right hand side first, in and out. So this one is a direction for the current how to flow. But now the question, they want to know the motor how to rotate. Either clockwise, either anti-clockwise. So we're still using our Fleming. So north to south. So we point like this, north to south. Okay, now we see this one current. Can you see the direction? The arrow is come down. Come down, if I stand from here, I can see this one direction is come to myself. This one is far away from me. This one come to myself. So I just point north to south. So I take out my second finger, point myself. When I point myself, I take out my thumb. Okay, thumb is go upwards. Mean this part, the force is acting upwards. So understood? Another side is go downwards. So this one how to rotate. One up. Okay, example, this one is a coin. One is up, this one is down. So I have to rotate. I up first, then I down. So this one we call clockwise direction. Okay, so now one up, one down. So now it's a clockwise direction. The motor blade, they rotate by clockwise direction. So your answer is just right clockwise direction. Okay, what modification they require and make sure this whole thing I want to convert become AC motor. Just now is DC, is it? Now I want to change become AC motor. Okay, remember what we learned for application before that? You can learn about AC motor, is it? We go and see the diagram. Okay, this one is a AC motor. You see what's the difference this one with the DC motor? Okay, first one, you find it. Okay, we're never using battery. This one is an alternating current. So we're using power supply. Then make sure your power supply, you turn to the alternating current. Okay, the next one, can you see the commutator? Take out the commutator. Now we replace by one pair of the slip rings. So this one, after you replace all the thing, they will become AC motor. Okay, so from here, how we write it? We just write, okay, replace. Okay, replace the commutator with a pair of the slip rings. Number 2, replace the battery with a power supply alternating current. Okay, 2 things. Okay, the next one is a AC dynamo. Okay, what means of the dynamo? Dynamo is a generator. Okay, generator means we no need using the power supply. After that, you still can produce the electricity. So this one we call generator. Okay, generator normally we using motion. Okay, you go to turn faster, just like your bicycle. Then you ride your bicycle faster, then after that the light, they produce the light, is it? So that one using the example for dynamo. So from here they say I want to produce an AC dynamo. So what you need to do? So first one, still no battery, because AC dynamo generator no battery one. So you take out the battery. Okay, then the next one, you replace, because AC is it, so you must replace the commutator with a pair of the slip rings also. Remember, when DC, we're using commutator. When AC, we're using slip rings. Okay, so I will write the answer here. Student, we're going to see the answer for modification when become the AC motor and AC dynamo. Okay, first one is replace the commutator with a slip rings. One pair of the slip rings. And also you need to replace the battery with the alternating current power supply. So that's why they become the AC motor. Okay, the next one you become the AC dynamo. So that means same again, commutator must replace with the slip rings. Okay, after that you need to remove the battery, take out the battery because we no need using the battery, but we replace one of the galvanometer. Okay, you do one galvanometer, you can put about the bulb because we want the testing, is it the current produced or not. Okay, so this one is how we go to modify the DC motor become the AC motor and AC dynamo. Okay, the next one is the question. Okay, they got 2 diagrams to show you. Okay, one of the diagram, there's a difference. We see what's the differences because later the question sure is a compare to each other. Okay, now we're going to see the 10.1 and 10.2. They show about copper wire carrying current conductor placed in a permanent magnetic field. Okay, magnetic field produced is called catapult field. Okay, let's see the first part, both using DC supply. Okay, after that got one of the meter there rotate. Then we find it the needle should be the same direction. Okay, the next one is the thick copper wire is rotating. Okay, anchor for deflection. You find it the diagram 10.2, the anchor become bigger to rotate. The next one different is the magnet. Okay, let's see the magnet in the diagram 10.2. The magnet become thicker. In the diagram 10.2, the magnet become thicker. Thicker means a powerful magnet, so we can say the strength of the magnetic field now is increased already. Okay, so now we continue with the question A. What means by catapult field? Okay, catapult field is you need to combine with the 2 magnetic field. Finally, they produce a resultant force, is it? So this one catapult field, we answer by like this. Combination of magnetic field from where? Produced by the current and also permanent magnet. So this one we call catapult field. Okay, the magnetic field from the current and also magnetic field from the permanent magnet. So combined together, we call it as a catapult field. Okay, the next one, okay, we go to underline. Actually, here got 3 marks. Okay, first one they call you to compare the number of the magnet. So number of the magnet used, 1 mark. Second one, compare the direction of the copper wire. Copper, not copper. C-O-P-P, yeah. Okay, number 2, compare the angle for deflection of the copper wire. Number 3 is compare the angle deflection of the ammeter. That one, the meter is the ammeter. So now we go to write by sentence. Okay, first one, number of the magnet, which one bigger? should be 10.2 lah. So we just answer number of the magnet used in diagram 10.2 bigger than 10.1. Okay, or you say more. Okay, number in 10.2 is more than 10.1. Okay, the next one is an anchor for deflection of the copper wire, and you just copy the question. Anchor of deflection of the copper wire in the diagram 10.2 greater than 10.1, or you say the anchor become bigger. Okay, the last one, they ask about the ammeter deflection. So anchor of deflection of the ammeter in the both diagram, how? They should be the same. So we just copy the question. Anchor deflection of the ammeter indicator in both diagram equal. That's all. So this one is a 3 marks comparison. Okay, after comparison, they sure got relationship. Okay, let's see the relationship, what they want. Okay, they want relationship between the strength of the catapult field. First one, with the number of the magnet used. So strength and number magnet used. So which one should be the MV? Which one become the RV? Normally the number of the magnet is the MV lah. So we mention the MV first, later is the RV. So from here we just answer as the number of magnet used increase. So as the number of magnet used increase, so you comma, then you continue with the question. Strength of the catapult field produced also increase. Okay, both is directly proportional. You also can write the word by directly proportional, but you need to mention the whole sentence must be full. Okay, the second one is a anchor of deflection of the copper wire. So now you want to make the relationship, the strength and also anchor deflection. So now we need to find out which one MV, which one should be the RV. So from here, MV now should be the strength. Okay, RV should be the anchor of deflection. So from here, we mention the MV first. Okay, when the strength of the catapult field produced increase, okay, then the next one, anchor of deflection of the copper wire also increase. So you mention the strength first. Because of the strength, finally the anchor deflection increase. Both also increase. Okay, then we go to question D. Okay, question D, let I draw first. Okay, student, let's see the question D. Okay, question D, they show about the setup for the study for the effect for the magnetic field of the current carrying copper rod. So that means the center should be the copper rod. Okay, now they say explain what happened to the copper rod when the switch is turned on. Okay, when the switch turned on, what happened for the copper rod? So from here, we need to use it is a Fleming left-hand rule. Okay, either the rod is go to the left or go to the right, just like this one. So from here, we go and do the explanation. Okay, from here, can you see the question is 2 marks. So 2 marks, maybe you can say where they move. Number 2, you say about reason. Why they will move? Because of the resultant force to push it. Okay, so now we go and see the Fleming left-hand rule. Okay, by using the Fleming right-hand rule, north to south, so I need to point downward first. Okay, now the current, how to flow? We label the current. Okay, this one is current, how to flow from the circuit. Okay, important is the copper rod. The copper rod below the magnet. So can you see the direction is come to myself? When I come to myself, then I just point downwards. Second finger you take out, then you point yourself. Okay, I point myself, then I find it, my thumb is point to the right hand side. So that means finally this one, copper rod, they will roll out. Okay, they will roll to the right hand side, that means closer with the battery. So we just write your answer is copper rod will move to the left side, right side or left side. Okay, copper rod we point again. Now, okay, now the current is, okay, sorry, I draw wrong about direction. For your notes, the battery should be negative first, positive, negative, positive. So the direction should be reverse. So I redraw again the direction. Okay, now the direction is go in. After that, until this part, the arrow is far away from me. So far away from me, that means I need to point north to south. Far away from me, this one finger, they're very hard to rotate. So you need to rotate to the in the board. Means the thumb is go to the left hand side. So very easy only, we don't need to turn so hard. We just assume now north to south still the same. Okay, north to south. So from here, I assume now the current is come to me. Come to me is go where? Go to the right hand side, is it? So now this one current is far away from me. Far away from me means the opposite direction. One is go right, just now go right, is it? So that means now the rod, they will move to the left hand side. So you can point, okay, point myself. Okay, now I need to rotate. Okay, when I rotate the thumb, is go to the left hand side. So that means finally the rod, they will go to the left hand side. So 2 marks. You mentioned about left hand side, you need to explain. So I just write the answer here. As the switch turn on. 2 marks, you add some extra for the explanation. As the switch turn on, interaction of the magnetic field, produce a force on the copper rod. Finally, copper rod move to left side. Okay, so this one is a 2 marks. So I'm talking about the interaction and also the force. Okay, number 2, they say the dry cell now they replace with the 12 volt but AC, alternating current. So explain what happened to the copper rod when the switch turned on. So if we're using the DC, I find it they turn one direction only, is it? If I'm using AC, what do you think about the copper rod? So the copper rod, when this way of the current, they turn to the left, is it? So when every half of the circuit, so you find it the current will be reverse. When the current just reverse, you find it the copper rod will move to the right hand side again. Then later, reverse again the current flow, they will go to the left hand side. So you find it the copper rod just go forward a little bit, then turn to backward, forward and backward. So this one is what you can see when I'm using alternating current. So from here, your answer is just write the copper rod move forward and backwards. So this one is what I can see because of the direction current changing. So we write with full sentence, the copper rod move forward and backwards due to direction of current changing. Okay, due to direction of current changing. Current keep changing. So that's why the copper rod also change about the movement direction. Okay, the next one is the motor. Okay, DC motor because they're using the battery. Okay, now this one they show you the north and also the south. They just want to explain how the motor able to rotate 4 marks. So just 4 marks, that means you no need to write step by step. You just overall. Okay, overall, how to explain? The first one must say the current flow. So from here, we start with number 1, current flow. Okay, when current flow, that means they produce a magnetic field, is it? So the magnet also got magnetic field. So number 2, we must talking about interaction. Interaction between the 2 magnetic field. Then what happens? They will produce force. Now got how many force? 2 forces. Okay, number 3, you must talking about forces. Okay, 2 forces to produce. But these 2 forces, the value, or you say the magnitude, should be the same. If you move up 2 Newton, another one move down must be 2 Newton. Then you add 1 more point, but these 2 forces in opposite direction. Same magnitude, but in opposite direction. Then finally, you just talking about how the coil to rotate. Because this one diagram, they show you the direction, there's a clockwise, is it? So the last one you just mentioned. Finally, the motor coil rotate in clockwise direction. So this has a 4 marks, how we write the sentence. So I label for you the 1, 2, 3 until 4. So you create your sentence to write the answer. I also will show you the actual answer. You write first, after that I show you the sample, then you find the keyword. Okay? Okay, now we go to the number 2. Suggest 3 modifications that need to be done on the DC electric motor to increase the efficiency. To increase the motor efficiency means you want the motor rotate faster. So that one is the efficiency. So from here just got 6 marks. 6 marks you can write in table form. Then after that, they want 6 marks means 3 points only. You give the 3 points, after that give the explanation. How to make the motor rotate faster? So from here, rotate faster means the force lah. You want to increase the force. First one must be the magnet. You want to make the strength become stronger. Number 2, you want to make the current become higher. Okay, this one is a 2 point. So we go to answer the first one. Okay, use the powerful magnet. First one, you say your aspect is use the powerful magnet. What's the reason? Increase the strength of the magnetic field. Okay. Number 2, you say increase the number of the battery. If you increase the number of the battery, so your answer is, I know the strength also increase, but we cannot mention the same of the word for the explanation. So we're using another word to explain. So from here you can say increase the current flow through the motor. If you're using number of the battery more, that means now you increase the current flow through the motor. Okay, the third one. Okay, for this one coin, actually there's a turning of the wire. Turning coil of the wire. For this one, turning coil of the wire, that means you can say increase the number of turn of the wire in the coil. Okay, increase the number of the turn in the coil. If we increase the number of the turn of the coil, that means when they rotate, okay, they're more cutting the flux. That means they will more 90 degrees. When they move, that means magnetic field and also the coil, they will cut about the flux. Flux, we call it magnetic field. So from here, if I'm using the number of turn, remember the solenoid. Solenoid, when I'm using the number of turn more, that means you can increase the strength. So from here, I can say, I also cannot say about the strength, is it? Because crashing. So we just say, when I increase the number of the turn in the coil, I increase the speed of rotation of the motor. Increase the speed of rotation of the motor. Okay, so this one is another one. Okay, so from here, just 3 marks, 3 points only lah, because it was 6 marks. So I also will show you the actual answer by using the table form. Okay, now we go to the last one. Last one is one of the experiment. Okay, let's see what they want. We find out the physical concept first. We got 2 physical concepts here. After that, we do the experiment by relationship. Okay, diagram they show about the device. They want the testing efficiency of the toy helicopter rotor blade. Okay, from the diagram you can see that the number of the blade is in number of the battery increase. Different of the number battery, the blade is the same. Just you find in the second diagram, the blade rotate become faster. So from here, if I increase the battery, means I increase the current. Okay, then the blade rotate faster means I say the speed become higher lah. So from here, that means we make sure we got 2 physical quantity here. One is a current, another one is a speed for rotation. Okay, so from here we also can find it one of the hint from the apparatus. Let's see the part C. Part C, they say they use apparatus, they're using the connection wire, magnet. Okay, we got magnet means we just got one experiment we're using magnet. It's just now what I show you. The second one, they say U-shaped iron yoke. They understood U-shaped iron yoke. So that means the diagram should exactly same like the first part diagram. So later we need to create the experiment, follow this one diagram. So this one diagram is what the copper wire, is it? So you want to let the copper wire to move. Because finally when you just on the current, then the copper wire, they will rotate, is it? So speed, how we measure the speed? We cannot using the ticker tape to measure the speed, is it? So from here, we're using the distance to represent the speed. So that means how far the copper wire can be moved, that means we represent the speed become higher. If you go further, means your speed become very high. So this one is another thing to represent the speed. So from here, you need to create the experiment. So you need to mention the ammeter because you want to measure the current. Okay, ammeter. When got ammeter, you want to adjust, is it using what? Rheostat. So that means the whole circuit later, you need to put ammeter and also the rheostat. Okay, after that, setting is the same. The diagram should be the same, just you want to add ammeter and rheostat. Okay, you need to mention is the distance where they go. The distance, the copper wire to move. So distance from here, what you need to add for the apparatus, there's a meter rule. Okay, you need to mention the meter rule in your apparatus, if not cannot function. So from the procedure, so you need to mention procedure is a switch on. You must have this word to switch on. If not, the whole experiment cannot function. Number two, you're talking about adjust. Adjust the rheostat until the ammeter reading show what is that the reading. You must mention the reading because there's an MV. Then after that, you're using the meter rule to measure the distance, okay, of the copper wire to move it. Then finish. Then you just repeat. Okay, remember, so you need to write the report. So MV should be the current. Okay, RV should be the distance of the copper wire move. That one is a RV. Constant variable. So what should be the constant variable? The constant variable, you are talking about the magnet lah, because never change the magnet. You can say about strength of the magnetic field. Okay, that one is the constant variable. So you go to create the experiment, then you write your diagram, label your diagram, and also the procedure. Okay, I will show you the actual answer. Later you can check is it correct or not. Okay, that's all. So from here we finish our tutorial 3.2. So the coming soon I will go to the chapter 5. Remember last time I said during holiday I want to give the extra class. Now we cannot go to school, is it? So I will continue the chapter 5 by using the YouTube. So I will prepare the chapter 5 notes in the Google Classroom. You can go to download. After that I will upload again the YouTube about the chapter 5. So we got one more class tambahan. There's extra class that's during the second week of the holiday. So there's a Thursday early morning. I think better I'm using the Google Classroom to teach it about the chapter 3.3. Okay, 3.3 or either tutorial 3 lah. We see we can until which part, so I will tell you. So this one is what I want to send to you. Thank you for your watching. So hope you can study well in your home. Okay, thank you everyone. See you again.